Here we go.
Thank you very much. So I want to do three things today. First of all, introduce the Energy Technologies Institute, because I'm pretty sure most of you, if not all of you, don't know who we are. Talk about the energy transition that's facing the UK over the next 35 years or so, and go a bit more into detail just for this audience. What does that mean for near-term investment opportunities or technology development opportunities? So, what is the ETI? The full answer is we're a private-public partnership dedicated to accelerating the development of low-carbon technologies. Our investors, our members are those five major corporates you see there, and UK government. We invest across the space of low-carbon energy and energy efficiency, all the way from offshore wind, marine, to bioenergy, to energy efficiency in homes and vehicles. What's a more helpful way of thinking about us? Well, we're a strange mix of strategic think tank and early stage investor. Hopefully it makes a bit more sense when I've gone through this. On the strategic side, we're independent. We've invested over £10 million to date in a whole energy systems analysis suite. We do technology innovation management and road mapping, and we deliver very complex innovation projects. We have over 70 staff, very highly qualified and experienced, core strategy team doing the modeling and that kind of thing, of 20 people, but subject matter experts across the space. And we advise in that role to government, to industry, and increasingly to investors. Also an early stage investor, very different model, but based on the outputs of our strategic analysis, we make decisions on where best to invest our £400 million budget. Where can we make a material impact on decarbonisation in the UK sector? We can't, unfortunately, invest on a reactive basis. It has to be on an RFP basis. So we have partnerships of over 100 organisations to date, 106 investments to date. Many of those are non-commercial, so they're purely for development of data, knowledge, and dissemination. But many are commercial, so we have equity investments, debt, and royalty structures in our portfolio. And it's a loop. So the resulting insights from all of those investments, where possible, IP considerations taken into account, we feed that back into a strategic analysis and improve that we've been doing this over 8 years so far. And also, where possible, we disseminate those insights broadly, like we're doing today, to stimulate the entire market. We're influential, as you can see there from some of those quotes. Hope you can read that. Government and large corporates and the academic sector take into account our strategic analysis, and it helps inform their strategic viewpoint of the future. So, what is the energy transition of our context? You see there a recent insight we published preparing for that transition over the next 10 years. What's the context? Obviously increasing demand, population, vehicles, housing, some action to date in terms of particularly the power sector and energy efficiency in cars. Huge amount left to do. Aging power plants need replacing, but there's a lot of potential. Wind, offshore wind, marine, tidal. Offshore carbon dioxide storage potential, biomass, and a lot of public support to underpin that. But on the flip side, poor housing stock, very significant heating challenge. So, one of the interesting insights came out of that is we believe that the UK can achieve an affordable transition. By affordable, we mean 1% of GDP. But system optimization is key. So what this graph is trying to say is, in a perfect world, perfectly planned and decarbonized world, it's going to cost you maybe 1% of GDP, £300 billion. But if you make the wrong choices, you don't listen to us, basically. So we have no building packages, retrofits for existing homes, no nuclear, no CCS, no bio. It's going to cost you twice or even 3 times that figure. So system optimization choices now are key. So going forward, we think it's achievable in a cost-effective way, commercializing known technologies and integrating them. Need to focus on a basket of leading contender technologies, not one single one. Some of those are mentioned there, efficiency, but also nuclear, CCS, bio, offshore wind, etc. CCS and bioenergy, in our view, are particularly important in reducing that cost of the system transition. Perhaps not for this audience, but for people with bigger pockets. To avoid wasting investment, we need to make decisions now. So what does that mean for this audience? There's opportunities now to invest and also to develop solutions. And I'll talk about some of those opportunities now. Talked about CCS, biomass and nuclear, very high ticket, obviously, require government intervention. But there are opportunities which are investable now and perhaps even without policy change. Waste gasification, grid reinforcement, offshore wind, home energy and smart systems, for instance. So, going through some of those. Bioenergy, we talked about its importance for the overall system cost, but it's also very versatile. You can get heat, power, gas, and liquid transport fuels from that. And our analysis, detailed analysis of the land use in the UK and the carbon emissions, we believe it's feasible to provide a significant amount of power from the biomass sector by growing in the UK. It's not a particularly well-known fact that although only 35% of renewable electricity comes from biomass, bioenergy, 60% of renewable energy does come from this, if you include heat and fuels. What are the opportunities coming from that? Apart from biomass with CCS, things like crop growth, aggregation, standardization, flexible processes and boilers, biomass district heat, fuel production and distribution. A lot of very different and diverse opportunities there. Waste gasification is a particular part of bioenergy. A lot of waste generated, 330 million tons per year in the UK. Currently, a lot of that goes to landfill, or there are a smallish number of large boiler plants. But from our perspective, the opportunity is really in smaller plants, 5 to 20 megawatts, low carbon energy for small towns and industrial estates. We've invested in the likes of Syntec and Royal Dahlman, and that's an opportunity to unlock 10 gigawatts in the UK, taking 90 million tons of waste. Heat, home energy monitoring systems, our consumer insights say that what we have at the moment isn't doing the right job for the consumer. They want more control of time, effort, and money, but they also really want to control their comfort in an easy way. Retrofitting homes looks like a large ticket, 100 billion, but it's much more cost-effective than some of the other choices we talked about earlier. Decarbonizing heating, 2 real options: individual home systems using electric heat, so that's heat pumps, etc., and local air schemes using heat networks. So the opportunities, as said, advanced integrated home monitoring systems. We believe so much that there's nothing out there at the moment that's doing it. We've started developing our own in-house. Home energy retrofitting solutions, district heat networks, and heat pumps. Energy storage and distribution, grid reinforcement. Had a lot today about energy storage, largely on the small scale. A lot of investment going in there. We looked at more distribution scale energy storage. We're investing in pumped heat electricity storage, and that's going through proof of concept at the moment. Wide range of opportunities from home scale to distribution scale. And the distribution scale mustn't be forgotten. It's not quite as sexy as the small scale, but it needs to be there. Large capacity, high efficiency, and rapid response. A couple of projects you might be interested in this space that we're currently going through. We're reviewing all the energy storage options, small to large scale, looking at potential uses and impact on the overall energy system. We also have a study of consumer behavior for electric cars and their impacts on infrastructure requirements. And one interesting aspect coming out so far from that, the demand side management, the smart systems we talked about, will have an impact on the overall system cost. And additional interesting aspect of that. Also in grid reinforcement, we talked about energy storage, balancing, etc. But you shouldn't forget, with a more distributed energy system, there's going to be a lot more faults, so there's a lot more complicated grid system. So we've invested quite a lot in fault current limiters. Grid-On are going to talk after me about their particular solution. And these can help renewable energy generators and in small industrial units get onto the grid much more cost effectively and more quickly. So low-cost, robust fault current limiters, let's Grid-On. And you can see the numbers there, but I'll let Yoram talk a bit more about it in the future. So, a little bit ahead of time. You'll be glad for that. Good dinner coming up, lunch coming up. If you want to know more, I've only touched the surface there. We've got a lot of publicly available insights on our website. If you can't find them, talk to me and we'll point you in the right direction. But we're also now directly engaging with third parties, consultancy, bespoke strategic analysis, could be technology road mapping, could be due diligence. Come and talk to me afterwards. My colleague Maria's in the audience somewhere. Thank you, Maria. Okay, thank you.